Okay, on a clean sheet of notebook paper or computer paper, whatever you'd like to do, you are going to write these 4 examples down. Yes, they're going to be worth points, so make sure you write them down. Yes, you need to show all the work like I'm showing you on the screen. If you do not have the pieces I'm showing you on the screen, you will not get credit for the calculation. Hear me? You must show your work as modeled in these examples, both here on these 4 examples and in your practice and on any assessment. Here we go. So percent composition is basically the percent of each element in a compound. So we'll start by calculating the molar mass. So this is example 1. Please just write this on your notebook paper for example 1, SRO. Pause the video as needed to catch up with things. So remember, to do the molar mass, we'd list the elements, S, R, and O. We would list how many we have of each element, 1 SR, 1 O. Then we'd multiply it by the periodic table number. 8762, that's the molar mass number, periodic table number, and then 16, so multiply across for subtotals and get your grand total. So this is how we do a molar mass, which we had done previous to this lesson. Now, to get the percentages of each element, you're going to divide the subtotal by the grand total. So you will take the 8762 divided by the grand total of 10362, and then this is important, so hear me, you need to have 4 places past the decimal. 4 non-zeros past the decimal. So if you have a bunch of zeros, you have to keep going until you have 4 non-zeros. So here we have 4 non-zeros. I rounded this 6, either stayed a 6 or round it from a 5 to a 6, depending what was after it. I don't have that on the screen right now, but you would want to round. So there's 4 non-zeros after the decimal. Then you're going to multiply that by 100 to get a percentage of 84.56. All right, so then next you'll take the subtotal of oxygen, divide by the grand total of 103.62. Again, you're going to report an answer so it has 4 non-zero decimal places. This one already has 4, so whatever was after this 4 either made it stay a 4 or made it go from a 3 to a 4. Then you'll multiply by 100 and get 1544. These totals here, for every problem, should add up really close to 100. If they don't, then you've made a mistake. Okay, this is example 2. Please jot this down on your paper. Pause the video as needed. Again, you're going to calculate the molar mass of Mn2O5. So remember to do that. We list the elements we have, Mn and O. How many of each? 2 and 5. Their individual molar masses. Multiply for subtotals and get a grand total. Okay, so once you have your grand total, then you'll take each of the subtotals, divide by the grand total. So we have 109.88 divided by 189.88. We're going to get a number. Make sure it has 4 non-zero decimal places past the decimal. Multiply by 100, and then you get 87%. For oxygen, 80 is the subtotal divided by the grand total. Again, getting 4 places past the decimal, multiply by 100. And you get 42.13. Again, add those up to make sure they're really close to 100. Again, you must show your work. So your paper should look like this if you want full credit, if you want any credit on this problem. Your paper should look like this for each problem. Okay, place this down as example 3. Again, you must show all of your work to get credit on this problem. So here we have an example. We're going to calculate the molar mass. Remember to do that. We list the elements R, U, N, and O. How many of each do we have? 1, 7, and 21. Remember, a number outside the parentheses for molar mass gets distributed or multiplied through the stuff inside. That's how I get 7. 7 times 1 for nitrogen. 7 times 3 for 21 for oxygen. Look up their molar masses for each. Come up with your subtotals and your grand total. To figure out the percentage of each, and we take the subtotal of each, divide it by the grand total. So we'll start with RU. 101.07 divided by 535.14. So divide those two. Get an answer with 4 places that are non-zeros past the decimal. Multiply by 100, and we get 18.89%. For nitrogen, we're going to take its subtotal divided by the grand total. And then we come up with 4 non-zeros past the decimal. Multiply that by 100, you get 18.33. For oxygen, divide by the grand total, the subtotal of oxygen by its grand total. You get 62.79. Again, 4 places past the decimal that are non-zeros. Multiply by 100, and you get 62.79. You will add these 3 up, and you should be very close to 100. Give or take 0.0 something, maybe 0.1. It could be 99.99. 100.01, 100.03, 100.1, somewhere really close to 100. Again, you must show your work as modeled, so all of this should be on your notebook paper for every practice problem and every assessment problem you do if you want full credit. Okay, final example, example 4. Please jot this down, pause the video as needed. So we're going to calculate the molar mass. We have NB, C, H, and O. We have 3 NBs, we have 24 Cs, we have 20 H's, and 28 O's. Look up their molar masses. Multiply across to get subtotals, add them up to get your grand total, and then to get the percentage of each, we're going to take the subtotals divided by the grand total. So for NB, we take 278.73 divided by 1035.17. We're going to get an answer. We're going to round that to 4 non-zeros past the decimal, and multiply by 100, and we get 26.93%. For carbon, we're going to take the subtotal divided by the grand total. We get 0.2784, again, 4 non-zero places past the decimal, times 100, and we get 27.84. For hydrogen, we get 2020 divided by 1035.17, subtotal divided by grand total. We will get it, here's what I mean. So I need another number on here, so let me find what that is. Let me pause that for just a moment. I'll be right back. Okay, so when I took 20.20 divided by 1035.17, I got 0.09513.703, so that'd be 0.01951. So I have to keep going because I need 4 non-zeros past the decimal. So that's a 0, so I gotta get 4 more. So this 1 is followed by a 3, so it stays a 1. Multiply by 100, and I get 1.95. I'm still going to round this to 2 decimal places, but I want to make sure that it's not going to end up rounding it up or down. So even though I have 4 non-zeros, I'm still going to round to 2 places past the decimal on all of these answers. Okay, then the next thing is 448 divided by 1035.17. I get 0.4328. 4 places past the decimal that are non-zeros times 100, and I get 4320. And again, all 4 of these should add up right at 100 if you've done this correctly. Reach out if you have any questions. Again, make sure you're showing all of your work as I modeled here, both here and in your homework and on your assessments. Thank you.